this is how the look like. That's the flow. So that is write a program. Hi, welcome to online tutorial series on Arduino and IoT. This is a project video, and in this video we will learn how to use ultrasonic sensor to make a object following robot. Okay, so we also provide online training, help in technical assignments. We also do freelance projects based on Matlab, machine learning, data science, Python, embedded system, etc. We also help students in their MTech and PhD thesis. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org. You can also mail us at jcbrolabs@gmail.com. Okay, so in our last video we talked about how to interface an ultrasonic sensor and how to use it in order to measure the distance of an object. Right, so in this video we will be using that information in order to create a project in which we will be making a robot which should follow an object and which should stop if it is at a particular distance from the object. Okay, so all these things we will be using with the help of this ultrasonic sensor. Okay, so let's start. First of all, let's give you a brief overview about the robot which we are going to make. Okay, so so here will be our robot, and it will be having an ultrasonic sensor in front of it. Okay, so pardon for my drawings, it may not look like an ultrasonic sensor. So what will happen, this is an object, so okay, object. So this ultrasonic sensor will send waves to it and will receive the reflected wave from it and measure the distance. So our logic will be following like this. If this range is about 9 centimeter, then it should stop, right? And if the distance is let's say it or if a robot is very near to it, right, it should turn back. And if a robot is greater than this 15 centimeter distance, it should turn forward. Okay, and in this range it should remain stopped. Okay, so let me clarify it. Yeah, right, so what is happen, this is 9 centimeter, right, and this particular distance is 15 centimeter, this is 9 centimeter. So if our robot is between 9 to the distance of the robot is between 9 to 15, it should stop, but no, it should not move. And if a distance is less than 9, that means a robot is very near to the object, right, it should move backward, right? And if the distance is greater than 15 centimeter, that means that is robot is very far away from the object, it should move forward towards the object. So that will be our simplest algorithm. So in this way we can create this object follower robot, and if it will adjust its distance from the object, let's say from 15 to 9 centimeter, and it will remain in that range only. Okay, so let's see how we have created our object robot. So on robot we have two DC motors. So one motor is there and another motor is there, right? We already know we need two wires to connect these motors. So this is right motor and this is left motor, right? And here we have our ultrasonic sensor which will be having these devices to measure the distance. Okay, so now let's see how we have connected our circuit diagram, or how we have connected these different components to the robot, so that you can replicate at your end if you are making this one. Okay, so here we have our Arduino, right, and this ultrasonic sensor, as we know, have 4 pins: VCC, trigger, echo, ground. Okay, so this trigger pin of this ultrasonic sensor is connected to pin pin number 3 of the Arduino, and this echo pin is connected to pin number 2 of this Arduino, and then ground is connected to ground, and then VCC is connected to plus 5 volt. And as far as this motor are concerned, so there are total 4 motors are there, total 2 motors are there, so each motor have 2 wires, right? So pin number 5 and 6 are connected to a right motor, let's say pin 1, and right motor pin 2. We can specify it like this. And pin number 9 and pin number 10 are connected to right motor pin number left motor pin number 1 and left motor pin number 2. So this is how these 2 motors are connected. Now, why we have used these 2 motors? So if you look at carefully, this pin number 5, 6 and 9, 10 are also the PWM pins. Okay, so let's say if your motor are turning too fast, so they have high RPM, so you can use the PWM to control the speed. Okay, so if you are using PWM, so otherwise you have to change the pins after writing the program. So that's why we have used these 3 pins. So either you can use as general purpose input output, or in order to turn or in order to vary the speed of the motors or the speed of this robot, you can use the PWM as well on the simultaneously. Okay, so now we will write a program. Okay, prior to that, let's have a look on the hardware, how we have connected it and what several components we may be needing for this program. So hi, let's have a look what component we may require for this project, for this obstacle following project. So first of all, we need a chassis in order to make a prototype. So it should have wheels. Right now we have connected it. These are 2 geared DC motors, and these wheels are connected to it, and then there is a caster wheel to support the entire system. Okay, and obviously we need an ultrasonic sensor to measure the distance of the object, and then we will need this L29 3D motor driver circuitry. So here we have it, and we have our processor, that is right now we will be using this Arduino Uno. And apart from this hardware, we may need some jumper wires in order to connect several components, and we may need some other toolkit in order to arrange everything. Okay, so these are the minimum hardware which may need it. Hi, so this is our final assembled robot prototype. Here we have ultrasonic sensor which are connected to in front of the robot in order to measure the distance from obstacle. And here we have Arduino, and we have provided this power lithium ion battery, provided the power supply from this lithium ion battery. And from this Arduino board we have provided VCC and ground to this breadboard, and from this breadboard we are providing the power to this L29 3D driver circuitry and to this ultrasonic sensor and to the board. So this is how this robot looks like in assembled form. So let's have a slight different look. Okay, it's look like this, and now we will write a program for our algorithm, and then we will test it in real time. Okay, so you have seen the hardware connections and how we have created the robot. Now let's write the robot. Let's write the program for the robot. Now what we will be doing, we will be implementing one module at a time, and then we will be checking it. and then we'll move forward. So first module which will be implementing it is the ultrasonic sensor. So first we'll write a program to interface the ultrasonic sensor, and then we will move with the interfacing of this with the interfacing of this DC motors. Okay, so I hope if you want to know like how this ultrasonic sensor works, so I should suggest you should see in our last video. In that video we have talked about interfacing ultrasonic sensor in detail. Okay, so let's first save this one. Okay, let's say on desktop. We'll make it as project 4, obstacle follower. Right, so let's save it. Okay, now first of all we need to define this trigger pin. So trigger pin is connected to pin number 3, and then echo pin, it is connected to pin number 2. Now in this setup, what we'll do, we will first initialize the pin. So all the one is trigger is output pins and echo is the inputs pin. So pin mode trig comma output type, and pin mode echo comma input. Right, and let's make this trigger pin set this trigger pin to 0, so that it remains 0 at the starting. And in order to see the distance calculated from this ultrasonic sensor, we will be sending data to the serial monitor. So serial dot begin, let's say at the rate of 9600. Okay, so let's clear it. Now in this case we know how to use this one. So in this project we will use functions. So functions are very similar to which we used to create in a C language. The only flexibility is we don't have to provide the prototype or the signature of the function at the starting. So we can start function writing from anywhere. So we will create a function, calculate distance, right, and it should calculate distance, and it should return the distance calculated by the sensor, right. So we will make a float return type of the sensor. Okay, prior to it, let's create two variables, float duration, right, and then because it will calculate the duration of the pulse, and then distance. Okay, and then it should return the value. So here we can write it like calculate distance, and yeah, it should not take any argument, because as soon as we should call it, it should return us the distance. So the procedure of calculating the distance from ultrasonic sensor is we send a high to low pulse of 10 microsecond duration on the trigger pin. So for that, first we will write digital write trig comma high, right, and then we will create microsecond delay of 10 microsecond, and then we will make a low pin digital write echo comma trig comma low. So as soon as a low pulse goes there, it sends a ultrasonic burst, right, and then now we should calculate that the duration. We should calculate the duration of the pulse. Okay, so for that we will calculate, because we have created this duration variable. So dur equals to pulse in. So there is a built-in function, and then add this echo pin, and then which state, high state. Okay, and then we should calculate this distance variable, right. So let's calculate dist equals to and it should be duration into 0.0343 divided by 2. Okay, I think we don't need to create any variable because these are two global variables. So let's see. And then distance is, it has calculated the distance. Okay, so now we will call this function into this loop, and then we will print it out on the serial port. Okay, so let's call this function calculate underscore distance. That's it. And then we will print serial dot println, which one is the distance calculated by in centimeter, and then we will make okay, so let's say to serial dot println distance in order to let the user know what we are calculating, and then we will provide a delay of 500 milliseconds. So at an interval of 500 milliseconds it should keep on doing it. Okay, so let's first burn this code into a microcontroller, okay, into our Arduino, and then let's do it. Okay, digital write, yeah, that is trig, comma, low. There was a typo. Let's compile it again. Okay, calculate distance was not dist. Again, a lot of typos are there. So it is uploading a program. Yep, it has uploaded it. Now let's see a serial monitor. Yes, it is calculating the distance. So I am putting an object in front of it and varying it. Yeah, so this distance, it is calculating the distance effectively. Okay, so now we'll move forward. What we'll do, once the distance has been calculated here, now we will add a motors program into it, like when we want to turn on the motor, when we want to stop the motors. Okay, so for that let's define the motor pins, right? So int write underscore motor underscore 1, its first pin, that is connected to pin number 5, and then int write motor pin number 2, that is connected to pin number 6, and then left motor L underscore M underscore pin number 1 is connected to pin number 9, and then L underscore M underscore 2, that is connected to pin number 10. Right, now we need to define the pin mode of all these pins. So pin mode R underscore M underscore 1, that should be of output type. All these pins should be of output type, so let's copy it. And this is 2, and this is L, and this is L, and this is 2. So initial state, let's make it to 0. Okay, let's put it to here. Okay, so we'll initialize all the motors with an stop condition. Okay, so digital write R underscore M underscore 1 comma low. Okay, so digital write to left motor 1, left motor 2. Okay. So let's compile it. Let's say, hope there should not be any error. Okay, then compiling. Now we will write a program into void loop. So our logic is very simple. If the distance measured by the ultrasonic is in the range of 9 to 15 centimeter, it should stop. Okay, so we'll check it. Let's say if distance this variable has been updated with the distance because it's a global variable, so we can access this particular variable within the code anywhere, right? Okay, so we will write this function after. Okay, we'll write our logic here. So distance has been calculated from this function because we have called it here. So if distance is less than 9, okay, distance is greater than 9 and distance is less than 15 centimeter, right? So it should stop. Okay, so we'll write a function stop motor. Okay, so we'll write a function to stop the motor. So what should be there? Why we are intentionally using this function in order to make you people familiar with how to use functions in Arduino program. So this function, yeah, we don't need to pass any value there. Why? Because the functions have been pins of these motors have been initialized globally, okay, and they have been pin mode has been specified, so we can simply use those functions here. So we can use this one, digital write. Okay, so digital write left motor, okay, because it is a stop, so we'll update it like this, so it will remain stop. Okay, so stop underscore m. Now else if distance is less than 9, right? So what was our code? So let's go to theory. So we said if the distance is less than 9, it should turn backward. Okay, so let's make it, yeah, if distance is 9, so we can write a program backward, and then we can specify that one here, void backward, and everything should goes there. So yeah, you may not know prior to like on which pin we can get back, so you need to change or need to switch the connection in the testing phase. Okay, so we have tested it. So by writing this, motor was turning backward, that 101. If we write like this, it goes backward, and let's write the forward program again here, forward. Okay, so if we do opposite of the backward, it will move forward. Okay, so it's move forward. So if the distance was less than 9, it should turn back. Else condition, else case will be 1 when distance is greater than 15. So when the distance is greater than 15, it should turn forward, right? Okay, let's go there. If the distance greater than 15, it should turn forward. Okay, so yeah, this is our program. So okay, don't write it like that. Calculated distance, we will also print the status so that we can understand whether our program is working fine or not. So serial.println stop, right, and then serial.println forward, move backward, and then in this case it should move forward. Okay, so let's upload the program and let's see what it is saying. So right now our robot is static, we are just testing it. So let's monitor. So monitor, yeah. So distance is greater than 15, so it is moving forward. So let's make distance is less than 9, it is moving backward because right now it is very near to the object. and if the distance is in the range of 9 to 10 15 it should stop. Okay, so its program is working fine. Okay, so now let's test the program program on real hardware by turning the robot on. Okay, so let's so now we will connect the power supply to this board, and here we have our obstacle. So first of all, as per program, it should stop as soon as it comes near to it. Okay, so let's connect it. Yeah, it has stopped. Yeah, and if I move this obstacle in front of the robot, it should turn back. Okay, so these both the motors are not moving in at the same speed, that's why it is turning automatically. And if I take object bill far away from the robot, it should follow it. Okay, so this is how this our program works. Okay, so this robot is following the object and keeping a certain distance from the object. So let's take it straight. Okay, and okay. Yeah, and it should. Oh, wait. Okay, so it will adjust its distance automatically. Okay, the program is very fine. So I hope you enjoyed it, and as expected it is working fine. So you can try this kind of project at your end as well, and then can create several cool applications based on this ultrasonic sensor. Okay. Okay, so you have seen how the robot is moving, and it was moving perfectly, and I hope you understand it, the logic behind it and how to implement it. Okay, so I hope you understand a lot from this video. So I hope that's it for this video, right? And further, we also provide online training, help in technical assignment. We also do freelance project. We also help students in their MTech and PhD thesis as well. Right, so if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. So that's it for this video. Thank you.